welcome. This is an algebra video. We are talking about multi-step equations. We are on page 12 of your Algebra 1, Quarter 1 notebook. So we are going to solve what we are going to call special cases for multi-step equations. Let's look at number 1. Well, I definitely see that I need to distribute. That's something I want to do first. So I see I have to distribute the 3. 3 times x is 3x. And then 3 times negative 3 is positive 9. And that will equal 3x plus 10. My next step is to combine like terms. No like terms to combine, but I do want to think about my following step, which is to get all of my variables on the same side. I prefer to bring my variables to the left, so I'm going to subtract 3x from both sides. Well, I know I was subtracting 3x to get that over here, so on my right side, I end up with 10. But here on the left side, what's 3x minus 3x? Well, that's 0 too, so that cancels, and I have 9 equals 10. Well, we all know that 9 does not equal 10. This is not true at all. So this is the case when my result is an untrue statement. This is not true. I'm going to just put that as for my not equal sign. Then I have a situation where there are no solutions to this particular equation. No solutions. Let's look at number 10. Again, I see some distributing. I have 2 times y and 2 times negative 7. So 2 times y is 2y. 2 times negative 7 is minus 14. And that's going to equal 2y minus 14. I will say, at this point, I can see I have the exact same expression on each side. I know at this point what the answer is, but let's say you don't see it right away. No like terms to combine, but I am going to subtract 2y. I would like to bring my y's all together on one side. Well, 2y minus 2y is 0, so negative 14 is what's left. 2y minus 2y is 0 equals negative 14. That is a true statement. Negative 14 is always going to equal negative 14. When this is the case, I'm not at no solutions. This is absolutely true. So this is infinite solutions. Basically, all real numbers are a solution to this particular equation. I can substitute any value for y, and I will get a statement that is true. Final one is, let's distribute. I have 5 times x, which is 5. 5 times negative 2, I get negative 10, equals 2x minus 10. Now my x's are different, so I'm thinking something's going to happen. So I'd like my 2x to move to the left side. 5x minus 2x is 3x minus 10 equals negative 10. Now going to add 10 to both sides. That's 0, 3x. And negative 10 plus 10 on the other side is 0. So in order to isolate my x, I have to divide both sides by 0, or excuse me, 3. 0 divided by any number is 0. And really the point of this particular problem is that x equals 0 isn't always a common answer, but it's certainly 0 is a number. Now if I substitute 0, 0 minus 2 is negative 2. Negative 2 times 5 is 10. 2 times 0 is 0, so negative 10 is left. This is the valid solution. The valid and true. Alrighty. We're going to just wrap this page up with some proofs of multi-step equations. So going back to that idea of proofs justifying the steps. Of course, here it is a given. Guess what? If I'm given 5x plus 3 equals y, if y equals 23, that is what is given. That is the reason. Now, my next difference, I'm going to see that 23 was substituted in for y. So my justification here is substitution. I've substituted in an equal value for an equal value. The next one, I feel like a lot of steps are happening at once if you think about our previous examples. The first thing is we needed to subtract this a plus 3 to quote unquote become 0, go away. So you could add the opposite. You can add the same thing to both sides. So let's just say I add a -3 and add a -3. That's the property of equality, and that's of addition, right? And then you know that that results in a 0. So that is the inverse of addition. And finally, I know that 0 plus any number is just the number. And what the result is the identity. So in between this step and that step, I feel like these three properties are at play. Likewise, in between this step and this step, I feel like three properties are at play. I have 5x equals 20. Well, I know that if I multiply both sides by the same number, I have the property of equality, the multiplication property of equality. I know that multiplying a 5 by its reciprocal is the inverse of multiplication. And I know that if I have the inverse results in 1, if I multiply any number by 1, I get the number. So this is the identity of multiplication. I feel like this is a little bit more apparent in here, and this should have been example 2. So let's take a look at example 2. Our first step, well, this is the one they gave. This is given. My first step is going to be given. If I think about my going from here, line 1 to line 2, I can see that the 7x has been moved, or it has commuted before the number 5. So this is the commutative property of addition. Then I can see that the 3x plus 7x has been given an equal value, and there's a little substitution. Now I see that I have added -5 to both sides. We've got the addition property of equality. Then I see that 5 plus its opposite will result in 0. So that, of course, is the inverse property of addition. And I know that if I add 0 to anything, I get whatever I started with. That's the identity property of addition. By multiplying by the same number, 1/10, I have the multiplication property of equality. Any number multiplied by its reciprocal equals 1. That's the inverse property of multiplication. And last but not least, if a number multiplied by 1 is itself, I see the identity property of multiplication. That's it for this video. Thanks so much.